Breaking news: SpaceX's most ambitious Starship launch yet arrives in a groundbreaking development that's set to redefine space exploration. SpaceX is preparing for their 6th Starship launch, and this one's unlike anything we've seen before. Mark your calendars for November 18th, because history is about to be made in broad daylight. This isn't just another launch. For the first time ever, we're looking at a 4 p.m. local time window, promising unprecedented visibility of both the launch and, more excitingly, the spacecraft's dramatic return over the Indian Ocean. That's right, we're about to witness the first high-quality footage of a Starship returning from space. But the timing isn't even the most compelling part. SpaceX is pushing boundaries by deliberately removing sections of heat shield tiles, testing new re-entry profiles, and planning a spectacular Raptor engine relight demonstration in space. And here's the kicker. This marks the final flight of the classic Starship design we've all come to know. After this, we're entering a new era with Block 2. Welcome to Elon Musk 24 Hours, where we bring you the latest in space innovation and technology. Let's dive right in. The space industry is witnessing a pivotal moment of transformation, and at the center of it all stands the SpaceX's most ambitious Starship launch yet. The engineering breakthroughs we're about to witness aren't just incremental improvements. They're revolutionary leaps that will reshape our approach to space exploration. First, let's dive deep into the groundbreaking modifications that make this Starship launch unprecedented. The engineering teams at Starbase have completely reimagined the heat shield configuration. By strategically removing sections of thermal protection tiles, they're not just testing a theory, they're revolutionizing how spacecraft interface with recovery systems. The areas where the Mechazilla catch arms will make contact have been specifically redesigned. Learning from the dramatic Flight 5 catch attempt, where we saw those massive chopstick arms dance with the super heavy booster before achieving that historic catch. The flight profile itself reads like a spacecraft test pilot's dream scenario. SpaceX isn't just pushing one envelope, they're pushing every envelope they can find. The ship will execute what engineers are calling an aggressive descent profile, with a higher angle of attack that will stress the aerodynamic control surfaces to their design limits. Every millisecond of this maneuver will be captured by an unprecedented array of sensors, providing crucial data that will influence spacecraft design for decades to come. But the real showstopper comes 37 minutes into the mission. In the pristine vacuum of space, Starship will attempt something that's only been theorized until now: a controlled Raptor engine relight. This isn't just a technical demonstration, it's a crucial capability that was originally slated for Flight 3, but had to be scrubbed when the spacecraft experienced unexpected rotational dynamics. The ability to reliably restart engines in space isn't just important, it's absolutely essential for future deep space missions, whether they're heading to the Moon, Mars, or beyond. The Super Heavy booster itself has undergone a complete engineering overhaul. After the heart-stopping moments of Flight 5, SpaceX engineers went back to the drawing board. They've implemented multiple redundant systems in the propulsion architecture, strengthened key structural points, and completely redesigned the post-catch propellant offloading sequence. The flight control software has been rewritten from the ground up, with new parameters that should prevent the kind of near misses we saw in the last flight. This mission marks the end of an era, the final flight of the Block 1 Starship design. Starting with Flight 7, we'll enter the Block 2 generation, featuring dramatically redesigned forward flaps, expanded propellant capacity, and a thermal protection system that builds on everything learned from these early flights. It's a testament to SpaceX's rapid iteration philosophy. What used to take years now happens in months. Speaking of rapid progress, let's shift our focus to another player in the commercial space race. Sierra Space has been making waves with their Dream Chaser program, though not entirely in the way they planned. While their first spacecraft, christened Tenacity, has faced delays pushing its launch to May 2025, the company isn't standing still. They've already begun construction on their second spaceplane, Reverence, marking a significant step toward regular commercial space operations. Recent photos from Sierra's facilities show the early stages of Reverence's construction, with the basic fuselage frame taking shape. The company's timeline suggests a 2-year build cycle for each spacecraft, a schedule they're working to accelerate. Each Dream Chaser is designed for 15 missions, and with NASA already contracting 6 cargo resupply missions to the International Space Station, the future looks promising for this innovative spacecraft design. The Dream Chaser program brings something unique to the table: the ability to return sensitive cargo to Earth via runway landing, reminiscent of the Space Shuttle, but with significantly lower operational costs. The spacecraft's versatility is enhanced by its companion cargo module, the Shooting Star, which can operate independently and provides capabilities beyond what current supply vehicles offer. Sierra Space isn't just building hardware, they're creating infrastructure. Their new Mission Control Center in Colorado represents a significant investment in operational capability. The facility will maintain a direct link to NASA's Johnson Space Center and will be staffed by a dozen specially trained personnel. These teams are currently running intensive simulations in partnership with NASA and United Launch Alliance, preparing for every conceivable scenario their spacecraft might encounter. Meanwhile, on the other side of the Pacific, China has unveiled something that's raising eyebrows in the space community. At the Xi Air Show, they've displayed a scale model of their latest Long March 9 rocket concept, and the design seems surprisingly familiar. The Chinese Deep Space Exploration Laboratory had hinted at this change a month ago, but seeing the actual model confirms what many suspected. They've taken more than a few pages from SpaceX's playbook. The Long March 9's evolution tells an interesting story. It started as a conventional design with a massive core stage and 4 side boosters. Then it morphed into a more streamlined, single-core reusable booster with 30 engines, already showing SpaceX influence. Now, with their latest iteration, they've essentially created their own version of Starship. While some might cry foul, the reality is that physics doesn't play favorites. There may well be only one optimal design for a fully reusable heavy-lift vehicle, and SpaceX simply got there first. But perhaps the most exciting development in space exploration isn't about getting to space. It's about what we can see once we're there. NASA has just integrated the revolutionary Roman coronagraph into their Nancy Grace Roman Space Telescope, and it's a game-changer for exoplanet research. This instrument, roughly the size of a baby grand piano, represents the cutting edge of astronomical technology. The coronagraph is an engineering marvel, combining masks, prisms, detectors, and self-flexing mirrors into a system that can block out the overwhelming glare of distant stars. This isn't just an incremental improvement over current technology. It's a fundamental shift in how we search for exoplanets. Instead of relying on the transit method, waiting for planets to pass between us and their stars, we'll be able to directly image and study these distant worlds. Set to launch in May 2027, the Nancy Grace Roman Space Telescope will offer a field of view 100 times larger than Hubble. But it's more than just a powerful telescope. It's a pioneer for future missions. The technologies being tested here will pave the way for NASA's ambitious Habitable Worlds Observatory, the first telescope specifically designed to search for signs of life on exoplanets. The rapid launch preparations at Starbase highlight SpaceX's dedication to pushing boundaries. What once took 3 months between flights has been compressed to just 1 month, a 66% reduction in turnaround time. This isn't just about launching faster, it's about learning faster, adapting faster, and bringing us closer to the day when space travel becomes as routine as air travel. Weather monitoring for this launch has reached unprecedented levels of sophistication. The afternoon launch window presents unique challenges, requiring consideration of thermal conditions, upper-level winds, and maritime conditions in multiple landing zones. SpaceX has developed new weather criteria specifically for this mission profile, ensuring optimal conditions for both visual tracking and vehicle performance. The mission control team has been running continuous simulations, preparing for every conceivable scenario. They've developed new contingency procedures specifically for the high-angle descent phase and the Raptor relight attempt. These procedures have been refined through countless hours of simulation and analysis, ensuring the team is ready for anything this groundbreaking mission might present. Every aspect of this mission has been instrumented to capture more data than ever before. New sensors have been installed throughout the vehicle to measure everything from thermal loads during re-entry to the precise forces experienced during the high-angle descent maneuver. This data will be crucial for validating design decisions and informing future improvements. The implications of this mission extend far beyond a single launch. Success here would validate multiple new technologies simultaneously: the modified heat shield design, the high-angle descent approach, the Raptor relight capability, and the enhanced booster recovery systems. Each of these elements represents a crucial step toward making human life multiplanetary. As we stand on the brink of this historic launch, one thing becomes crystal clear. Space exploration isn't just about reaching new heights. It's about pushing the boundaries of human innovation. From SpaceX's groundbreaking Starship modifications to Sierra Space's persistent progress, and from China's evolving space program to NASA's revolutionary telescope technology, we're witnessing a renaissance in space exploration. The sixth Starship flight represents more than just another launch. It's the culmination of countless innovations and the gateway to a new era of spacecraft design. With each test, each modification, and each daring maneuver, we're one step closer to making space travel as routine as flying across the globe. I'm excited to continue bringing you the latest developments in space technology and exploration. If you found this deep dive into the future of spaceflight fascinating, make sure to hit that like button and share this video with fellow space enthusiasts. Your engagement helps our community grow and keeps you updated on all things SpaceX and space innovation. Don't forget to subscribe to Elon Musk 24 Hours and hit the notification bell to stay informed about all the latest developments in space exploration. Drop your thoughts about these groundbreaking developments in the comments below. I'd love to hear your predictions for the upcoming launch. Until next time, keep looking up. The future of space exploration is brighter than ever.